Welcome to the Illinois Sustainable Ag Partnership's third annual Risk Management Conference. We framed this year as a three-part webinar series. We're glad you're here. I'm Jill Costell with the Wetlands Initiative and chair of the ISAP Steering Committee. ISAP works to create a network to support a systems approach to improve soil health and reduce nutrient loss. The 12-member organizations work collaboratively throughout the year to provide consistent technical assistance to Illinois farmers and advisors on soil health and conservation drainage practices. For the best experience possible, we got some simple Zoom tips for you to share. If you hover over the bottom of your screen, the bottom bar should appear with the Q&A and chat functions. For this series, we won't be using the raise hand function. During the webinar, be sure to submit your questions for the keynote speaker and panelists through the Q&A function. Questions can be uploaded there as well. Please use the chat function only if you're having audio technical issues. Before we get started, we have a quick poll to gauge who's in our Zoom room today. This poll will help our panelists frame their conversations as well. Thank you for voting. We appreciate that. Now let's get to it. Our keynote speaker, Eric Snodgrass, is here to share what climate Illinois producers should expect in the upcoming years. Eric?
All right. So before I get started, I want to make sure, can we all see my screen okay? All right, I'm hoping that everything's showing up here. Well, I appreciate the invitation to and kick this off. And with the time I've got today, what I really want to be talking about here primarily is going to be changes that we have been observing in precipitation across the state and across the country. In the video in the background, I just want to remind you something that's quite amazing about our atmosphere. At any given time, the Earth's atmosphere holds around 3.43 quadrillion gallons. But the way that it distributes it around the world is quite amazing. There are some places on Earth that we have not measured precipitation. We estimate as long as 120,000 years. This is actually in a place called the Atacama Desert, which is in Chile. And then there are some places that receive annually 500 to 1,000 inches of rain a year, specifically like the Big Island of Hawaii has been known to get up to 500 inches of rain, or the front range of the Himalayan mountains in India and Bangladesh can get at times 500 to up to 1,000 inches of rain a year. It's amazing to see what that distribution looks like. What we really want to be asking ourselves as we work through this talk today is the distribution around us, where we farm here in the state of Illinois, changing? And is it measurable? And what are the practices that could be put into place such that we could continue to, one, measure and understand, and two, continue to be resilient and profitable as, things like shifting climates impact what we're doing? So all of this boils down to what happens to these two maps as we move forward into the 21st century. I pose a question at the top. Are weather and climate factors systematically changing changing in a way that will affect these maps? These are maps I think you've all seen before. Over there on the left, we have county level corn production. These data are from 2018. And you can see where we grow a lot of corn here in the United States. But over there on the right, maybe that's a map you haven't seen. What it is showing is yield variance. So I took data from 1980 to 2019, and I looked annually at how often yield varied around a detrended mean. And what was amazing in some of the data that we got here was that the highest variance seemed to be in the Dakotas, and it seemed to be down here along the East Coast into the Delta and then in parts of Texas. The lowest variance, of course, was in northern Texas, parts of Kansas and Nebraska. And I think you all know why. In that part of the country, there is a lot of irrigation. But right in through here, where we do a lot of dry land farming, we see yield variance runs right about the middle of the road across the United States. We would like to know, is anything changing that map into the future that could possibly increase or decrease our variance in yield? So let's get right on into this and talk about what we're going to go into today. If you have not heard, kind of nationally, the news has been the extremely windy conditions that have been occupying so much of the central plains of the United States. This was a video that was sent to me earlier this week out of Kansas. I thought that was a round bale rolling here, but it turns out it's some sort of container getting blown across the road by some extremely dry conditions. Yet at the same time, across sections of the US, specifically with the tropical storm Cristobal, we have had intense downpours of rainfall, like the one that you see over here on the right-hand side, that has just at times put down tremendous amounts of rain. I want to show you something neat. I tweeted this out the other day and also put it in some of my weather briefings, but I think you should all see this particular map. Over the last 30 days, I dug into the data and I found the daily average surface wind speed and compared it to normal. And what we notice is that almost across the whole of the United States, this last 30-day time period, so basically mid-May to mid-June, has been exceptionally windy. But this corridor right in through here has seen wind speeds that have on average been between 6 and 10 miles an hour faster per day. And as a result of that, look at what we've done to our soil moisture. So you can see where Cristobal went through right in through here. The map you're looking at shows you soil moisture change since the beginning of the month. And with those strong winds coming out of the desert, where we've had a lot of fires in parts of Arizona, and coming out of central Texas, we have managed to sap out of the soil anywhere between 1 and in some locations up to 5 inches of water. Remember, this map is in millimeters, but 100 millimeters is 4 inches. And there are a few places right here in parts of Oklahoma and Kansas that exceed those amounts. We've been dry on the other side of this as well here in the eastern part of the Corn Belt. And we do have a very critical forecast coming up in the next 5 days to see how much rain we'll be plowing across this part of the country. But these are the issues at hand. It's the delivery and the timing and the amount of precipitation. Now, I always get asked this question, so I'm going to just give it to you right here. Since last year, everybody wants to know, how do I compare to 2019? So that's what this map shows you. Now, check it out. It's the difference in total accumulated precipitation over this time period, March 1st to June 16th. Anywhere that you see blue, that is where we were wetter in 2019. And any place that is red is wetter in 2020. So yeah, there are places that are wetter in 2020, specifically parts of Iowa, Wisconsin, Michigan, and there's even a couple of pockets like right over here, almost in my backyard in Illinois, where due to some major rainfall we had back in May and in April, we're actually sitting above what we were in 2019. But the thing that we think about here is that the last 2 years were extreme in the amount of precipitation they have given us. And so I'm getting these questions a lot almost every spring from farmers. So we're getting these wetter springs. We're going to prove that in a few moments in the data. But the question is, how often do these wet springs, okay, lead to dry summers? So I would like to give you a little bit of information about this before we dig into these other statistics. What you've got here goes back to the year 1948. And the reason I start in 1948 is that is the beginning of something called the reanalysis project. And we kind of consider that the standard of measurement and the standard of processing of the data to begin at the beginning of the reanalysis project, which started in 1948. Now, when you look at this particular line graph, each column that jumps up there above, which is in black, represents a time period where we had a very wet spring followed by a dry summer. So when we think about the way that precipitation is being delivered, think about it in the context of how often we see massive variations in precipitation. For a lot of us in Illinois and Iowa, we think back to 2019, wettest spring on record, then followed by drought that developed in the month of July and August. Well, when you look at this particular map, I went through and I've kind of digested it here. And what I really want to pull out of this data set is just to show you that since 1980, which is this line moving forward, we seem to have more often years where we are much drier in summer after a super wet spring. But to put all of that into context, here's the first of 3 questions I want to pose to you today. 1, are Illinois growing season rainfall totals changing? Because we realize that we're getting precipitation differently, but what about the whole of April to October? Well, these data come from NOAA. They are statewide across Illinois, and I have overlaid on top of these data, which show you yearly, year by year, how much rainfall we got from April to October. What it shows you here is the trend from 1948, shows you the trend from 1980, and it shows you the trend from 1990. Now, just to let you know, when we do studies of Earth's climate, we should never ever use a time scale shorter than 30 years. So that's why there's no point in detrending the last just few years or even the last 10. The minimum is going to be 30 years. What we basically see over each of these time periods is that the April to October rainfall amounts for the state of Illinois have increased on average 5 inches. That is an increase of 5 inches. But as you all know, the delivery of that rainfall is changing. We want to talk about that delivery. So the next logical question, question number 2 before I get to that delivery is, are planting windows getting tighter? Now, I went after answering this question a few different ways. I'm going to specifically use a data set. It's very high resolution. It begins in 1981 and goes to present. It's called the PRISM data set. The reason why I use this data set is because it is the best data set that blends rain gauge data with radar data. And that map you've been looking at there in the background is looking at precipitation frequency trend. Now, what is that? This basically asks how much of a trend, in other words, the slope of a line, okay, do we have in our 1-inch rainfall events? And I colored in blue everywhere where those slopes are positive. And the numbers I want you to see across the state of Illinois are these. In terms of 1-inch and 2-inch rainfall events, just over the time period of April to May, we have doubled the frequency of those heavy rainfall events since 1981. In other words, as our rain is coming, it's coming in much, much bigger helpings. And as a result of that, it is closing up our windows for longer. So we're seeing some major changes in heavy rainfall events. And I think anecdotally, nearly everybody on this Zoom call here will agree with that. Now, an extension of this question, by the way, I do know we got one guy, at least from Iowa. In Iowa, the number has tripled, just so you know, it's tripled in Iowa. But here's an important number I want you to take home with you. So I went and I then looked at the length or the number of dry days that we have in April and May. And what I found out was simply this. When we look at how we're getting a change in the number of dry days, we are seeing across the state of Illinois a decrease in the frequency of dry days. So when you put together the increase in frequency of heavy rainfall events, followed by a decrease in the number of dry days, it's basically raining more often and raining more heavy. And here's a number to take home, 5 days. Over the 2-month time period that I'm talking about, April to May, we have seen a reduction in our planting windows by an average of 5 days when you compare the 1980s and 90s to the 2000s. Some years, that number is much, much, much larger, like 2019. But still, statistically, we've lost about 5 days of planting window when we think about how we get things going in April and May. So very critical point to take in there. All right, from there, I'd like to look bigger picture. And so on this particular map, I was curious what this distribution looked like across the United States. And I wanted a kind of more big block statistic here. So what I did was I took data from that same data set, 1981 to 1999, and I added up all the precipitation. I then stopped at 1999. I then went from 2000 to 2018 and added up all the precipitation during that time period. I specifically left out 2019 because of how big of an outlier it was. I didn't want it to bias the statistics too much. When you compare these two 19-year time periods, total precipitation 81 to 99, total precipitation 2000 to 2018, and you take the difference, what we find here is that when you get east of the Rocky Mountains, most locations are getting wetter throughout the entire year while the west is getting drier. And this is a long enough time period over which we've been calculating these statistics that we can't ignore it. Now, interestingly enough, Andy Zessin here put out on Twitter back on March 28th a great question. He's a young farmer, and he asked what on-farm investment has the highest ROI. Now, it was interesting. You got 188 responses to his question, and several of them were quite funny. People were telling him to marry rich and you'll be fine. But he's talking about return on investment. And what was the two most common replies, by far number one, was to put in tile. In other words, the amount of money you spend on putting in tile, you get back, over and over again when it comes to managing your water. The second thing, which came from a lot of farmers that were in the Western Corn Belt, was to put in an irrigation system. So it was all about management of water. So farmers we know are talking about these things. So here is my third question for you, and then we'll get to the end of this. Is there a trend in humidity in total precipitable water? Now, I think you're all familiar with what humidity is, but what's total precipitable water? We can actually measure how much in a column from the surface all the way to the top of the atmosphere, how much water is in it. And if we condensed it all and made it rain out, what's that amount? Now, for many of us, last week on Tuesday the 9th, we were getting moisture that was actually coming up from the Yucatan Peninsula, getting all the way into Illinois and Iowa. The air mass that had advected or moved out of the Gulf and hit this section of the United States actually contained moisture levels that are more typical of the tropics. And at one point, we had set a record here on Tuesday of nearly 3 inches of precipitable water. Now, it all didn't come out. A lot of it came out in Iowa, it didn't come out in Illinois. But that's what happens when a massive tropical system like Cristobal, which you see here, moves up the middle part of the United States. Now, let's get a little nerdy here. I wanted to know if there was a trend, and I immediately wanted to know what it was correlated with. So what you've got over there on the right is a graph that shows you from 1970, which is over here, right here, all the way to 2019, how minimum temperatures have changed and how precipitable water has changed. And the two data sets are very highly correlated. The correlation coefficient is 0.75, okay? When you see that kind of correlation, it makes sense because we know, studying basic atmospheric sciences, that the higher you make the temperature, the more moisture the atmosphere can contain. To give you some numbers to take home, since 1970, the state of Illinois has seen a 3-degree increase in its minimum temperatures, its overnight temperatures. That has led to a 15% increase in our total precipitable water. And therefore, the atmosphere is more primed to give us these heavy rainfall events. Now, we've been hearing this a lot lately in the news, right? People wanting to blame corn on the fact that they feel uncomfortable in July. Well, when we think about how broad of a sector in the mid part of the United States, we have put corn and soybeans and other crops, which by their design are just giant respirators, right? They just pull moisture out and put it into the atmosphere. Here's another number to take home with you. In August, when the corn is beginning to dry down, but we have quite a bit of heat, a typical acre of corn can evaporate 3,000 to 4,000 gallons of water per day. Now that information comes from the USGS. They've measured it, 3,000 to 4,000 gallons of water per day. And that moisture goes straight into the atmosphere. National Weather Service out of Des Moines tweeted it out last year trying to explain what this is, because the addition of the heat and the ability of the atmosphere to contain more moisture, then it'll fill itself up and we get bigger and badder thunderstorms in summer, like the one that you're watching animate over there on the right. By the way, we estimate that the top of that thunderstorm there, which is kind of bubbling there, is around 60,000 feet. One of the deepest storms we've observed. It's pretty amazing there. Storms like this contain, and this isn't an exaggeration, billions of gallons of water in them, and they are easily able to dump that out. Well, the moisture for these storms comes from, well, evapotranspiration, and it also comes from the Gulf of Mexico. So let's ask that humidity question. I got the same graph that's over there on the right. Now your R-squared value goes up to nearly 0.85. What do we see here? Across the state of Illinois, due to that 3-degree increase in minimum temperatures, we've actually seen about a 6% on average for the whole of our growing season, a 6% increase in relative humidity. And that's sizable. That's a lot more moisture that is in the air that can be recycled and put back out in precipitation. Now, as I near the end of what I'd like to share with you today, I would like to talk about some likely causes of these trends. And then we're going to put these questions up to our experts to discuss how things are being managed in terms of things like stream flow, sediment flow, and also nutrient loss. And we're also going to be talking about what farmers are doing to not only mitigate issues with excess water, but also to understand what they're doing to increase resiliency and return on investment. So this is my first thing I want to talk with you about. This is a snapshot on June 16th of this year of global ocean temperature anomalies. And yes, we've got ourselves a La Nina going right here. Now, what's interesting about this La Nina compared to big La Ninas in the past is that typically when we have a strong La Nina, we'll get cold ocean temperatures that extend all the way up into the Gulf of Alaska and all along South America. In fact, the last time we saw this was 2010 and 2011. There has been a noticeable trend specifically in the North Pacific, right inside that box I've showed you here. Let me get those drawings up there so you can see a little bit better. That the North Pacific upper ocean heat content has been increasing quite a bit from 1970 on. The last time you could even say that it was cool was back here in 2010, 11, and 12. Now, why tell you this? Well, if I'm increasing ocean heat content inside of this box, I am sensibly transferring more heat into the atmosphere, more moisture into the atmosphere, and this box is upstream of us given the normal westerly wind belt. And as a result of putting more moisture into that air, we are getting more moisture coming across the United States. And yes, we do get Pacific moisture into the mid part of the US. But in addition to that, this area has also seen a sizable increase in heat content, as has the Gulf of Mexico. Why does it look blue right now? Well, that was what the influence of Cristobal was. Whenever a tropical cyclone goes through, it cools off the water, but it's going to heat right back up. We are changing our ocean temperatures in a way that is putting more moisture into the atmosphere. And we're allowing that moisture to stick around by the increase in overnight temperatures specifically. In the long-term trend in terms of the flow of the jet stream, some research that's very powerful in understanding here is that we are seeing a systematic increase in ridging events. That's where the jet stream bulges upward and gets hot and dry. We're seeing more ridging events in summer out west and a broader troughs in the eastern part of the United States during the summer. What do we end up getting? We get something called northwest flow during that time period, which gives us a lot of thunderstorm activity. This is the kind of me piecing together some of the reasons as to why we are getting more precipitation. But really, it boils down to some very simple fundamentals of physics and thermodynamics. When it comes to an ideal gas, like what we have in the atmosphere, a mixture of gases, when you increase their temperature, you automatically increase their ability to contain water vapor. And that water vapor can then be condensed and it can be precipitated out. And where it's being precipitated out is what we want to know. So expectations for the 21st century, and these data come from the IPCC. These data have been vetted by over 3,000 separate scientists. This work is good work, and I have personally vetted some of this work. What we're looking at here is precipitation change. And if you needed to just take home a phrase or an idea, this is what we're finding. Places that are dry right now are getting drier. I'm specifically thinking about parts of the southern plains of the United States, Central America, Mexico, also Southern Europe, places in the Amazon and Australia. Places that are wet right now seem to be getting wetter and wetter and wetter. And that specifically, pertains to the Corn Belt of the United States. That is what the best research shows us as we move forward. So the questions I want to put to our panelists here as I wrap up my part is I want to know how this is impacting farming. My colleague and good friend Jason Little took this picture just a couple of weeks ago after the most recent extremely heavy rainfall in East Central Illinois. And we had ponding like this all over the state from some of the recent extremely heavy rainfall events. Because when we see this amount of rainfall, it gets us thinking about better water management strategies, right? Now, I've been showing this video for the last year. It's one of my favorites. I don't know what this guy's attempting to accomplish here, but clearly he's pretty excited about it, waving over to his neighbors. But this is clearly not how we're going to manage our water. So what I would like to do is I'd like to introduce you now to two panelists we're going to be able to talk with today, two experts. I'm going to stop sharing my screen here so we can go back and get a quick introduction for both of these guys. And so are we back on, let's see here. There we go. So we're going to talk with Keith Schilling. He's a state geologist out of the Iowa Geological Survey. And we're also going to be talking with Chris Reynolds, Midwest Ag Director for American Farmland Trust, and he's a Montgomery County farmer. And what we're going to be putting questions to these two guys about here are mainly going to be around mitigation strategies. They're mainly going to be around understanding what we're doing with water and how we continue to be resilient and how we can also increase ROI given the changes we've observed and seen in precipitation. So I saw some stuff did come in the chat. So I'm going to check this out very quickly first here. Were there any questions that came in that we should answer right now? Looks like none just yet, and that's okay.
Eric,
oh, yeah.
Excuse me. Actually, this was a question specific for you. It was posted under the
Sure.
question function. And
oh, okay.
The question is whether there's any difference in available days for field work if you look at a 1.5 inch rain or say 3 days in a row of a 1/2 inch rain.
Yes.
And this person just pointed out that the data is quite noisy on this.
It's extremely Yes. Oh no. That's a great question. If you don't mind, I'm going to share my screen again very quickly with him so I can show this one more time. Let's go back here because I think let's do share. Sorry about that. You might be looking at this particular slide here. Now, the reason why this is so noisy is because the way that I set this up is I used a very, very low threshold on rainfall. And what I did here was I set it at less than 0.2 inches per day. Now, why that makes it noisy and why you see all the dots all over this particular figure is that rain gauges can pick that up, and they're where the dots are. The radar often can't sample very well such light rainfall events. So when the product becomes blended, it does look a bit noisy like that. That's an excellent question. But you're right, as I go through and I start to massage and change the values, when we start to look at these much, much bigger events, I honestly think that this number is closer to a week to 10 days than it is 5 days when I did the analysis with the dry plus the 1 inch events. That's a great question. And I hope that that gets kind of takes a stab at answering that for you. So why don't we go back now to here. And I want to switch things over to Keith. Keith, if you wouldn't mind going and getting your screen shared, I'm going to lead in a question with Keith, and I hope that people on the call today can kind of come in with some questions. So we'll get his. There he goes. So Keith, this is what I'm wanting to talk with you about. All right, we're talking about consequences and the consequences of increased precipitation. Could you specifically elaborate on what this might mean in terms of nutrient loss, sediment loss, and also on river flows and drainage flows and stream flows? Keith, take it away.
Most of the increase that we see in rivers across the Midwest really occur in this time period from April to June. What does this correspond to? As Eric alluded to the individual farmer, this corresponds to drainage season. The bar graph on the left just shows that when drainage is expected to occur throughout the region, mainly from March to July, with most of the drainage occurring there. And as this shows up in the stream, we can see throughout the Midwest, including the upper Mississippi River Basin, that this increase in drainage at this time results in the low flow increasing in our rivers. And most of this low flow is again associated with the April to June period. So if we look at trends in base flow, the low level flows in our streams, we see that most of the increase is occurring during this drainage season from April to June and July. Well, if we increase drainage, it's no surprise that tile drainage contributes to high nitrate concentrations in our streams. So is it getting wetter? We put in more tile, and more tile results in more nitrate. As an example, in 2 watersheds in north central Iowa, heavily drained, nitrate concentrations from the tiles exceed 10 milligrams per liter 90% of the time. So that's not unknown to everybody, but that is a consequence of the increasing precipitation. And final consequences are, again, these are Iowa numbers, but I would imagine they would hold true for most of Illinois and the remainder of the Corn Belt, that our nitrate load leaving the state of Iowa has almost doubled since 2000. Some of this is rainfall induced, some of it is agricultural management. And these trends are even more prominent where it's a little bit drier in Iowa and western Iowa draining to the Missouri. So these trends, again, manifest themselves throughout the Midwest. Another Iowa example, but again, holds for everybody. As we get more precipitation, we're going to also get more phosphorus export. This was some work we recently published showing long-term total phosphorus export as yield, kilograms per hectare, from large watersheds across Iowa. And you can see that the western Iowa and southern Iowa, with steeply sloping agricultural lands, we see phosphorus yields there in excess of 2 kilograms per hectare. Along with the changes in discharge and nutrient export, we also see differences or changes in our federal crop insurance payments. These are national data that we've compiled for our counties in the state, but see that there's hardly anybody immune to filing federal crop insurance payment, getting payments for excess soil moisture, in this case, on the order of $150 to $300 an acre. On the other side, we see indemnity, large indemnities, payments due to drought, with many of these drought payments also exceeding $300 or $400 per acre. And over the course of the US and Iowa, we see this whiplash occurring back and forth between drought payments one year, excess moisture payments the other year. So this climate variability that we see is showing up in a lot of different areas. Now, one of the things that agriculture is going to be commended for is following the Dust Bowl era and the advent of the Soil Conservation Service and the USDA, there's been a huge ramping up of installation of best management practices for reducing excess surface runoff and soil erosion. In Iowa, we've had a project where we've mapped these conservation practices using LIDAR and color infrared photos, and we see huge investments made in structural practices on agricultural lands. The Silver Creek Basin on the right is in eastern Iowa, and just you can see from the 1960s to 2016, the large increase in conservation practice implementation here, from grass waterways and terraces and water and sediment control basin. If you look across Iowa, after mapping 1,700 different Huck 12 watersheds, we see nearly 115,000 dams and almost 90,000 miles of terraces constructed across the state. So agriculture needs to be commended for taking these kind of actions to reduce excess soil erosion from rainfall runoff. And we see this showing up in the data. Again, another Raccoon River example, but my colleague and I, Chris Jones, looked at water quality trends of sediment over the 20th century, and we see a major decrease in sediment in this watershed that is typical for many locations in the Midwest. Again, these upland conservation practices are really having a difference. But we wonder if we're shifting these sediment sources from the uplands to the stream bed and banks, where we've taken practices to reduce it on one hand, without changing the stream energy and get more increasing discharge. Are we picking up more bank erosion in our phosphorus and sediment export? We had a project in Iowa where we looked at GIS, land cover data, and LIDAR high resolution elevation. And we looked at locating where we think stream bank erosion is occurring in the state. And we estimated over 35,000 kilometers of streams and rivers may be severely eroding in the state. This would represent approximately 41% of all of our small to medium-sized river miles. So it's quite significant, and we're probably picking up a lot of that input today in our total sediment and phosphorus export. We use this data to estimate what the contribution of stream bank phosphorus is to total phosphorus export. Looked at a lot of different characterizations there, and what we see is that almost 8,000 metric tons of bank erosion sediment compared to the Iowa stream export. A third of our total sediment or total phosphorus export from the state is probably coming from bed and bank erosion. Finally, I want to conclude here. It's like, why is this hydrology relevant to nutrient export? If you look at just a simple stream flow hydrograph showing discharge increasing over time following a rainfall event, it's important because we have different processes in export occurring based on where you are in the hydrograph. The storm flow, the rapid rainfall runoff, is relevant because this contributes to phosphorus and sediment to our streams, as opposed to the subsurface pathway, like the base flow, groundwater, and tile drainage discharge, which is relevant to nitrate and phosphorus, dissolved phosphorus transport. Finally, you ask, why is this relevant? Well, the hydrology is linked to our solutions. So if we want to take care of the storm flow component and reduce phosphorus and sediment transport, we need to be concerned about the rising and falling limbs of the hydrograph and focus our practices on ponds, buffers, terraces, and conservation tillage. If our focus is going to be focused on nitrate, dissolved phosphorus transport, then we need to focus on the base flow part, including nutrient removal, wetlands, and controlled drainage. You know, one practice that covers all aspects of the hydrograph is going to be to increase our soil health through cover crops, extended rotations, and CRP. So there are some things that we can do, but we definitely need to be aware of the changes in our stream flow and and how increasing precipitation has changed our stream flow and implicated consequences for nutrient export. Okay, that's it for me. I'll be happy to take any questions.
We will there's a couple questions, Keith, but I do want to make sure we have time for Chris. So I'm going to hold those for a discussion afterwards. And maybe we can just, Eric, if you have a question to lead Chris off.
Yeah. So Chris, thinking about what I just presented, what Keith just presented, thinking about water management on the whole, you know, the questions that come to mind are, you know, and I just kind of jotted these down while we were doing this because, you know, what are farmers doing in response to narrowed windows, and what are farmers doing to kind of mitigate some of the stresses that Keith was talking about? We heard about some structural changes in their land, but if you could maybe talk a little bit about tillage practices, conservation practices, and ultimately, how does this all positively feed back on the return on investment side of it? So I'd like to hear you talk about those things, Chris. Thank you.
Yeah, well, thanks, Eric. You know, I want to give a little background on myself. You know, as you alluded to earlier, you know, I'm both a farmer and also work for American Farmland Trust and as the regional director. And you know, I've spent my entire career working in ag conservation. The first part of my career was with my local Montgomery County Soil and Water Conservation District, and that's really where my passion for, you know, conservation on the land first began. Back in 2012, I attended, it was the very first cover crop conference. It was hosted by Warren Buffett or Howard Buffett Foundation here in Central Illinois. And that's really where my soil health journey, both personally and professionally, began. And most of my conservation work, you know, up to that point, have been using structural practices to try to eliminate gullies and reduce soil erosion. And it was really less about promoting the infill management practices to help reduce soil erosion and improve water quality. And so we know now, you know, the best way to decrease the soil, water, and nutrient runoff is really to couple those structural practices with the infield conservation practices, the conservation cropping system practices that include no-till, cover crops, and also nutrient management. You know, and as you mentioned, I'm also, you know, blessed to be a fifth generation farmer on my family's farm in Montgomery County, Illinois. And back in 2013, planted my first cover crop and have been utilizing cover crops ever since. And I really feel like those experiences, you know, as a farmer, have helped me educate other farmers about the benefits of cover crops and a soil health management system. And really these, you know, experiences have also helped me recognize, you know, the challenges that we face today in adopting new practices and also working to develop ways to get past those challenges. And so, you know, really farmers today are, you know, they're experiencing these much narrower planting windows that you mentioned, Eric. And, you know, they recognize that they have fewer suitable days for planting in the spring. And because of this, they've increased planter size. You know, my farm operation is about the same as my dad's and grandpa's was 20 years ago, and our planter is twice the size of what it was back then. So farmers are increasing their planter size. They've also invested in new technology to allow them to plant faster, get over more acres, you know, during the same time period. And even starting to see a lot of farmers that are running multiple planters at the same time to have the ability to plant corn and soybeans during the same time period. You know, we've seen over the past few years a lot of advantages to planting soybeans early. And for the first time this year, I planted all my beans in April, and about 2/3 of those beans went in before I ever planted any corn. And most of those were planted into green cereal rye, and also had the opportunity to let some of those covers grow and provide some additional benefits that maybe I wouldn't have seen if I had terminated them earlier. And as Eric, as you mentioned, we're also seeing, farmers are also seeing larger and more intense rainfall events more often. That allows for fewer days between rains for the soil to dry out. Farmers are also seeing erosion in fields that have not normally been prone to erosion. Our flatter fields that we don't consider highly erodible land, we're starting to see a lot of erosion take place in those fields. And this is often the ephemeral gully erosion that we use structural practices to fix, that farmers are noticing in those fields, and really it's the sheet and rill erosion that is the most concerning when we look at the amount of sediment that's being lost, and that type of erosion often goes unnoticed, but really contributes to a much larger percent of the soil being lost from a field. And also because of these larger rainfall events, we've also seen an increased amount of water runoff from the fields. This runoff, is carrying nutrients that otherwise would be used for a growing crop. So we see an increased amount of runoff if the soil is already saturated, or the soil is sealing off at the surface, not allowing water to infiltrate into the soil profile. So cover crops and no-till as part of a soil health management system really provide us with protection from these weather extremes. They're protecting the soil surface, they're allowing more water to infiltrate the soil. And when we have a conventional system where we're using tillage, that soil surface, as I mentioned before, is a lot more prone to sealing off and leading to ultimately more water running off into our streams and waterways. During wet springs, we also see cover crops having the ability to increase water uptake. As that cover crop is growing, it's helping to dry the soil out faster. Even this year, when we had some potential for some late frost damage, we saw some of these fields that actually had warmer soil temperatures and less damage to the soybeans that were more protected by those cover crops. We're also seeing, herbicide resistant weeds they've really become a huge concern, and farmers are really starting to see the benefits of using cover crops as a weed suppressant. And I think that's one area that in the future we'll see an increased usage of cover crops as we try to tackle, some of the challenges that we have there. And that's also directly correlated to, the wetter springs that we have, the inability for us to get in and terminate weeds earlier. They get more growth on them, makes them harder to terminate later on. And so if we can keep the weeds down and suppress them with the use of cover crops, we will have a much greater success doing so. We're also seeing a lot more farmers that are planting green into the cover crops, and they're having great successes doing so. As we all know, the 2019 planting season was probably, the most difficult season of my planting career, and probably many other farmers as well. Record rainfall, delayed planting across the Midwest, even prevented planting in many areas. We had a record amount of prevent plant in Illinois. We saw farmers doing, cover crops after prevent plant, some opportunities there to keep the soil covered. But we also had a lot of farmers that were planting into cover crops for the first time that year. And by the time they were able to get into the field, whether it was late May or early June, the covers had a significant amount of growth on them. And, I had the same experience on my own farm, but when I talked to other farmers, they told me that there was the two similar messages that I heard from the farmers is that, they were really concerned going in to try to plant into that tall of a cover crop, typically cereal rye. But they also found that it was really a lot easier than what they had expected, and they had a lot of successes in doing so. And the second thing was that farmers recognized is that there was no erosion in those fields, and where they saw a significant amount of erosion when they were finally able to get into their other fields where maybe they were doing some tillage, you know, the fields where they had cover crops, you know, were really protected, and no erosion was taking place. Of course, that means, you know, we're not losing nutrients as well. You know, in regards to, you know, as you mentioned earlier, we've seen an increase in tile going in. From my standpoint, you know, tile has made doing conservation practices a little easier at the same time. We know that it can be a very leaky system, but there's also some advantages to being able to get cover crops seeded, being able to get them terminated. And so it's good that we take a look at the system as a whole and try to manage each individual field based on its soil types and the conditions that are there. You know, the Precision Conservation Management Program came out with a lot of great information this year, you know, looking at the economics of these practices. And, you know, one of the things I want to highlight is that, you know, when farmers are doing less tillage, whether it be, you know, mulch till, reduced till, or no till, you know, they're seeing a greater return on that in that system than if they're doing conventional tillage and doing a lot of tillage ahead of planting. We're also seeing farmers that are adapting, you know, looking at other ways to try to get cover crops seeded. It's sometimes a challenge to get cover crops seeded in the fall. So looking at vertical tillage as a way to get over several acres, you know, get several acres of cover crop seeded. Aerial application of covers is also popular sometimes when the conditions are right. And also there's other programs that are now available. You know, last year was the first year in Illinois that we had a premium program discount through crop insurance for cover crops. And so we're always looking for new ways to try to, you know, advance the use of cover crops, to show the benefits of cover crops and educate farmers about why cover crops are needed. And I really think is, you know, if we as farmers don't make some of these voluntary changes to our infield management practices, we're going to continue to lose soil, continue to lose nutrients, and ultimately face a little bit of pressure from potential regulations. So I think it's important that we, you know, we recognize that there's challenges, and we try to figure out, you know, how best we can get past those challenges and adapt and adopt some of these conservation practices.
Thanks, Chris. Really appreciate it. I'm going to turn it over to Jean Brokich with American Farmland Trust and ISAP coordinator, and she's going to be moderating the Q&A. Jean.
Thanks, Jill, and thanks, Chris and Keith and Eric. So yeah, I think the first question, there's a few questions that have come in from participants, and I think the first question really is for Keith. You mentioned, you know, base flows are increasing in part because increased precipitation and intensity. A question was posed about, has there been anyone looking at what % of that increase is due to the fact that there's a change in land use, and maybe most specifically increased tile installations that might be moving that water more quickly to streams?
Yeah, hopefully you can hear me. I was reading through the chat. I didn't want to sound like Darth Vader, somebody said I sounded like, so I hope it's better now. Yes, that's a great question. We've done a lot of work on that topic. Clearly more water will result in more stream flow and base flow. We've tried to separate out the land cover effect, and we've seen that account for about 30% of the increasing base flows and stream flows. Now, tile drainage naturally shows up in the base flow fraction as we interpret that from hydrograph separation. So as land cover, it definitely has changed to more annual row crops of corn and soybeans. We're able, with tile drainage and that land cover changes and changes in evapotranspiration, we're seeing more, about 30% of that change in stream flow source to that change in land cover.
Great. And then there was kind of a question, I think both Chris and Keith kind of alluded to this a little bit about soil structure and these different practices and how they can increase or improve soil structure. Is there any like good data on soil structure and hydrology, soil hydrology, be it water holding capacity or runoff related data?
Well, this is Keith. I'll start, and then maybe Chris can have a different perspective. But clearly, the answer to reducing runoff, the first step is increasing soil health, increasing our infiltration capacity and water holding capacity with organic matter and more porous and hydrologic receptive soils. So I think that's a clear first step, and the science is pretty settled on that. As you decrease soil structure and you decrease infiltration capacity and storage, you're going to get more runoff. So I think that's been documented over the last few decades. So that's pretty well established.
Yeah, I would agree with Keith. I think it's a matter of, improving your soil health, increasing that organic matter to be able to hold more water, but also you have to have the ability to get the water into the soil profile. And I think that's what we see in a lot of these tillage systems is we see a slaking off of that surface, soil profile. And, I've went out in fields and dug down, 4 inches after a 2-inch rain, and the soil will be dry as a bone. And it's just, it's really incredible to take a look at that when you're, especially during a dry time. We here in this area, we haven't had rain in about 3 or 4 weeks now. And when I get a 2-inch rain, I want to be able to hold all of that water. I don't want to see it leave the field.
So one participant asked the question about whether there's any support to capture the water or to hold it for when that drought comes later in the summer, be it, maybe drainage water management. I don't know if any of our panelists have some expertise or some ideas about that they could share.
Last year, I watched them put in a saturated buffer over on I think it was on the Embera River in Champaign County. Fascinating to see what seemed to be pretty simple water, redirecting water to store it for later in the buffer along this gentleman's field. It was incredible to watch that put in. And I believe the system, he was able to control it with his iPhone, even like a little lock and dam system that, and if I remember correctly, I do not believe that the total cost was outrageous. Was it, I think, around 10,000? Does anybody remember if that's what the total cost was?
Yeah, that's pretty typical.
Yeah, and I haven't talked to him how he did the rest of 2019, but it was a pretty fascinating thing to watch. And those saturated buffers, I think, can very quickly prove to be great ROI.
Great, thanks.
Yep. There are probably opportunities for, storage ponds, possibly wetlands to store water that could be potentially harvested later in the season for irrigation. I think the jury is still out as far as making that cost effective and affordable. But, it's a shame that we get all this precip occurring in rapid fashion, that we can't store and hold it and then use it later, because all the precipitation that leaves when stream flow is not available anymore. So if we could do a better job of holding it on the landscape, we have a chance to use it later on.
So Chris, someone posed a question for you to see if you've seen other farmers willing to adopt these soil health management systems, and if they are, that's great. And if they're not, what can we do to help support that change?
Yeah, that's a great question. And I think we're seeing farmers that are trying, have been trying cover crops on a small percentage of their farm operation over the last several years. They're trying to figure it out. Is this something that they can adapt into their operation? There's, certainly a lot of challenges right now in farming. Commodity prices are low. The weather variability is also, I think, a challenge to some folks that are wanting to adopt these practices. So, I think that, we have to do a much better job of getting the information out to farmers, educating them, but also working with their trusted advisors, whether it's through the retailers, the CCAs, to show the benefits of these practices and try to figure out, you know, how we can fit them into their current operation.
One question came in. I think, Keith, in your presentation, you mentioned that about 1/3 of the phosphorus in Iowa is coming from streambank erosion. Are there types of practices that can help address that?
That's a great question. And unfortunately, what streambank erosion typically indicates is that there's excessive stream power that's driving into stream banks here or there, or down cutting and causing stream bank instability. So while there are definitely bank restoration practices out there, armoring banks and natural or riprap and so forth, they tend to just be a Band-Aid, and then the problem would move on to another location. So ultimately, the stream bank erosion is one that's going to have to be probably a long-term issue regarding stream power. And so reducing our stream power, reducing our stream flows or the erosive flows in our stream, which again traces back to improved conservation on uplands to keep the water slowed there so it does not, gush into a stream and start eroding the stream banks. So it's one of controlling the stream power as much as an individual stream bank restoration practice, which can work great in isolated cases. I mean, to prevent the bank erosion at one location, but it's not a solution to that statewide or regional problem.
All right, great. So it sounds like overall these soil health practices can do a good job keeping the soil, getting the water into the soil and keeping it there, and benefits more than just the fields, the stream banks as well. With that, I'm going to pitch it back to Jill, who's going to do some wrap up for us, and thank our presenters.
Yeah, thank you to everyone for participating, including Eric, Keith, and Chris, and the great questions from our audience. As we wrap up here, please claim your CCA continuing education credits. You can scan the QR code with your CCA app, or you can type your name and CCA number into the chat box, or just reply with your info to the follow-up email that will come this Friday. If you could please answer this quick exit poll. This feedback allows us to keep providing the most useful content to you. And while you're doing that poll, I'll just say a final thank you to the Illinois Council of Best Management Practices. In addition to supporting the broader use of Farm Doc's conservation lease addendum, they're also providing one lucky participant today a $50 Visa gift card, and we'll email if your name is selected. So thanks again, and we look forward to seeing you back here for next week's webinar, where we'll have Carl Zimmerman, Gary Schnickney, and Martin Barbary discussing how soil health management practices can increase working capital, a great risk management tool. Take care.